Hello and welcome to Math World. Let's talk about the substitution method. This is the second method we're going to learn for solving a system of equations. Alright, now to introduce this, let's take this single equation here. Now imagine if we had this equation and I gave you the value of one of these variables. If I said y equals 5. You could solve for x just like we did in class before by plugging in the 5 in for y, or substituting y for 5. We would then just operate like we learned in class. 2 times 5. That's 10. And once we get to a problem like this, we can use our inverse operation skills. And we see that the answer is 9. Alright, so we basically have been doing substitution before. It's just a way of plugging in for the variable we know. Now, can this be a little bit more complicated if we have a variable with our other equation? So let's see this one more time. This time, I'm going to make our second equation have a variable in it. Alright, so this time, let's try y equals 5x. And just for simplicity's sake, I'm going to make this number a 39. Alright, so what if I have y equals 5x? Well, I still can plug in y for what I know y is. Y is 5x. So now I'm going to get this problem 3x plus 2 times 5x. Just like before, I substituted y into 5. Now I'm substituting y as 5x. 2 times 5x is 10x. But now, luckily, I have like terms. 3x plus 10x is 13x. Let's bring down this 39 who was hanging out up there. And 13x, I can divide both sides by 13 to find that the answer is 3. X is 3. And now you see why I changed to 39. So, even though I have a variable, I can still plug it in or substitute it in. Alright, let's see it even more difficult. Now, let's do a system of equations. What if I have y equals 5x plus 3? We now have a full system of equations. One equation, two equations. And again, if y is alone, I know what y is equal to. Y is equal to 5x plus 3. Yes, it's a whole big complicated thing, but that's what y is equal to. So let's plug in this whole expression, 5x plus 3, since that's what y is. We'll plug that into our equation. 39 equals 3x plus 2 times, I'm going to put the whole thing in, 5x plus 3. The whole expression got substituted. Can I solve this? It looks pretty complicated, but I have skills. I can distribute. 2 times 5x is 10x. 2 times 3 is 6. Bring down the rest of my problem. I can combine like terms. And now this problem is looking pretty simple. So that's it. That's how we use substitution method. It's not going to be a whole number here to give us our final answer, but that's how we do it. It's 2 point something. Substitution method. Alright, let's put this all together for a final problem. Here's our system. I'm going to want to start with the side that has the variable isolated. Okay, so I have my variable isolated. Let's take this, what I know y is, and plug it into the other equation. 21 equals 2x plus 3 times all this stuff. I will distribute 3 times 4x, 12x. 3 times -7 would be -21. I have my 2x over here and my 21. Okay, combine like terms. I can inverse operate. The opposite of subtracting 21 would be adding 21. And inverse operate to find out that x is equal to 3. Alright, and that's actually only half the problem, because my solution should be an ordered pair. I need an ordered pair. All I know is that x is 3. I don't know what y is yet. So what I'll do is I'll take this x equals 3 and I'll plug it back into either of the problems. I can put it into this equation or this equation. I'm going to go ahead and put it into this equation because I think it's a little simpler to solve. I'll put it into this one. Y equals 4 times 3. Notice I took the x is 3 and plugged it into here. Minus 7. 4 times 3 is 12. Minus 7 is 5. Y equals 5. That is my solution. I now have my x and y coordinate. The ordered pair of 3 and 5 is a solution of that original system of equations. So, substitution method. Find the isolated variable, substitute in the variable, and solve for both variables. Well, that's it, and I'll see you in class. Hey class, it's Mr. Bigsby with a hat, and I've got a challenge question for you. Alright, I want you to solve this system using our newly learned substitution method. Alright, the first equation is 3x minus 5y equals 36. And the second equation is x equals -3y minus 16. Alright, so try using the substitution method, and I'm going to give you a little hint here. X is alone, not y. So think about, we had the value of x to substitute, not y. Alright, once you get your ordered pair, your value of x and your value of y that works for both equations, leave in the comments. Alright, later. Now for a word from our sponsor, Paper Cut Games. Now I know you all like card games, so this week is an old school little travel game called No Thanks. Now in this game, there's going to be a deck of cards that they're going to remove a couple of random ones so that you don't know all the cards in the deck, but the numbers are 1 through 36. And each time a card's going to come out, and the players will kind of say whether they want to take the card and add to their stack of points or say no thanks. And if you say no thanks, you take one of your chips and you put it on the card. Now the goal is actually to not get points. So you don't want the cards, especially a high one like 35. Now, people will say no thanks as they go around because nobody wants the 35, right? But eventually you're going to run out of chips. Or maybe you don't want to use all your chips up. You only start with about 8 chips. Or maybe you see 5 chips on there, because if you take this card, not only do you get the card, but you get all the chips. So yeah, you got 35 points, which stinks, but you have more no thanks power. And so each time a new card will come over, a 9, and players will take turns basically saying how many times they can say no to that card. Although a 9 maybe I want to take and pick up the 2 chips that come with it. So it's kind of an interesting game, and there's a couple scoring tricks, like if you get things in a row, it doesn't hurt you. And the goal is to say no thanks and not get the cards, not get the points. So easy little travel game, no thanks. Check it out. I'm Mr. Bigsby, and I approve this message.